Hi all, in this session we are going to learn about Docker. Here we can learn what is Docker, how to create Docker, where we are going to use the Docker, everything we are going to discuss in detail. Let us quickly understand what do you mean by Docker. Docker is a container management platform for developing, deploying and running applications. Means by using Docker as a container management tool, you can be able to develop your application, you can deploy your application and you can be able to run your application as well. Means the Docker is going to provide such kind of advanced features and compatibility where you can be able to host and run your applications. Docker is lightweight in nature because of even though it is carrying the OS files which is very negligible in size, and Docker is an alternative to virtual machine. Generally what we will do with the help of the VM, we are going to host our application. So if you want to host in an alternative method, then the Docker is going to provide such kind of compatibility. How you are going to deploy your application on top of the VM, in the similar way you can be able to deploy your application on top of the Docker container as well. And Docker is far more advanced than virtual machine because of it is going to provide such kind of advanced features. Means it is highly scalable, we can quickly able to deploy and easy to use, and it is light in weight. There are a lot of features, but Docker is far more advanced than virtual machine. Let us understand in detail what is VM and what is Docker, how far it is different. In order to understand, first of all we need to understand what is virtual machine. Here, as you know, generally we have two types of servers are there. Like if you deploy or if you install the hypervisor on top of the bare metal, that will be called as a type 1. Otherwise, if you are going to install the hypervisor on top of the operating system, that will be called as a type 2. Here we are going to discuss about the scenario 2, that is type 2 hypervisor. Here initially we have the bare metal server. On top of the bare metal server, we are going to host our operating system. That may be Windows OS or Linux OS. On top of the operating system, we are going to host or we are going to install the hypervisor. Hypervisor is generally used to virtualize. Means you are going to virtualize the hardware. Generally, on top of the hypervisor, what you will do? You are going to create the virtual machines VM. Means here if you have for your server, if you have some 48 GB of RAM, then you are going to share among the VMs which you are going to create on top of the hypervisor, like 12 GB, 12 GB, 12 GB RAM, 36 GB RAM, and the mission which you are going to create furtherly, you are going to allocate the space. Whatever the space which you are going to allocate, it is a fixed. It will be used dedicatedly for this VM. Means out of 48 GB, the 12 GB has been dedicatedly used for the VM1, and 12 GB has been dedicatedly used for VM2, and this 12 GB has been dedicatedly used for VM3. In this way, while creating virtual machines on top of the hypervisor, we are going to assign some kind of configuration. But from where it is going to assign? In server, it has a configuration. We are going to virtualize the server hardware. Here simply we are doing the same. Fine. So let us understand in detail then what the Docker flow is. Here in Docker, what will happen? In the similar way, we have the bare metal server is there. On top of bare metal server, I am going to install operating system. On top of operating system, instead of installing the hypervisor, what I will do right now, I am going to install Docker daemon or Docker engine. On top of the Docker engine, I can be able to create the containers C1, C2, C3. Containers. So containers are light in weight because of we are not installing operating system on top of the containers. Simply it is going to use the OS files of host OS. If you install the Windows operating system, it is going to use the Windows OS files. Suppose if you install the Linux OS, it is going to use the Linux OS files. Here we are not going to deploy the operating system on top of the container. That's why the containers are light in weight. Okay guys, I hope you got it. Fine. So we will go to the further slide. Here I'm going to show to some kind of practical examples. Assume you have a virtual machine. You have a virtual machine. You have 16 GB of memory is there. Memory is nothing but RAM. Whenever you see the memory, you can simply understand that is a RAM. Suppose if I had created VM1, VM2, VM3 on top of this server. Here I had been allocated 6 GB of RAM to VM1, 4 GB of RAM I has been allocated to VM2, 6 GB of RAM I had been allocated to the VM3. Total 16 GB. If I'm allocated the 6 GB of RAM to VM1, what will happen? 6 GB has been successfully allocated to this VM only, dedicatedly. Suppose out of 6 GB, if we had been used only 4 GB, then rest of the 2 GB you didn't use it. Even though you didn't use those 2 GB, but the 2 GB has been allocated to the VM1 only. The 2 GB space which has been allocated to the VM1 cannot be used by the VM2 because of it is dedicatedly assigned to the VM1 only. We can do like that. We cannot do the VM2 can use the unused space which is available in the VM1. Sorry guys. Okay. And if you come to the VM2, it has 4 GB. Out of 4 GB, 3 GB has been utilized. The 1 GB is unutilized. Can I make the 1 GB will be utilized for the VM3? No, it is not possible. And it is possible to create another VM and that can use the 1 GB space. That is also not possible. So here, out of 16 GB, I had already assigned all the GB to the VMs which I had created on top of the server. So here the total memory has been used is 9 GB and the total unused memory is 7 GB. So without using the 7 GB of memory, even though I didn't use, I need to pay the amount to the Azure. Why? I had created this resource over the Azure and I need to pay the amount for the total 16 GB. I am not going to pay the amount for the 9 GB because of even though you are utilized or you didn't utilize it, you had taken the 16 GB of RAM. It is your responsibility whether you can be used or not. But here the effective utilization of hardware is purely my responsibility. Then how? Here then the Docker comes into picture. Here let us understand the another scenario. The same 16 GB memory I have right now. So I am going to create the containers C1, C2, C3. Here I am going to allocate the memory. Here what will happen? The C1 is consuming 4 GB of RAM. The C2 is container 2 is consuming 3 GB of RAM. And the container 3 is consuming 2 GB of RAM. Then how much total GB? 4 plus 3 7, 7 plus 2 9. Here it is going to consume 9 GB. These three containers are going to consume 9 GB only, and means out of 16 GB 9 GB is only used and rest 6 GB is freely available in this server. And if I want, I can be able to create one more container, and out of 7 GB which is freely available on the server, I can be allocated to the container. In this way the memory is not blocked here. Containers is going to fetch the memory based on the requirement. It is not going to block the memory. Here if you compare the VM and the Docker, here VM is strong just like an elephant. It is in big size. Means what happened? Elephant is stronger now, it's a bigger in size, means it consists of lot of stuff. In the similar way, the Docker is just like a rat because of it is faster, because of it doesn't have OS files. If you start the VM, it is going to load the OS files. It will take some time in order to load the OS files. But if you start the Docker container, is it taken time? No, because of it didn't have the OS files. It is not taking that much time as VM is taking because of it doesn't have the OS files. And startup, if I start the VM, it is going to start as a tortoise because of it consists of OS files. But if you start the Docker container, it's like a kangaroo, like how much fast it is, because of it is not loading all the OS files. Simply it will start as soon as possible once you start the container. And integration, it becomes somewhat difficult or somewhat medium range, but if you want to integration, it will be very easy if you are using Docker containers. Because of this compatible features, advanced features, and effective utilization of the hardware, the companies are looking towards to use the Docker containers in order to host their web applications. Okay guys, and let us discuss how on more slides. And I have made some comparison chart here regarding virtualization. Here in VMs, the virtualization in servers hardware means in virtual machine we are going to virtualize the hardware, but coming to the containers we are going to make the virtualization at OS level. Standardization, VMs are standardized systems that have capable similar to that bare metal computer. Means even though it is a virtual machine, how the bare metal server is behaving in the similar way, the VM which we had created on top of the bare metal server is also going to behave like that only. There is no such kind of difference is there. Even though that is a physical machine or virtual machine, both are behaving same like. And containers are not standardized as their kernel OS has varying degrees of complexity. Resource management, each VM has its own kernel OS, binary and library. But coming to the container, is it having one kernel OS? No, it is using the host OS kernel. Okay, just I had made some kind of comparison here. Just please have a quick look on it, and we are going to move to the further slides. Then here you can use that Docker is a containerization tool. The vendor is Docker. Is it a open source? Yes. It is not the licensed version. If you are looking for the support, you can take the support by contacting the Docker, but it is a open source IT containerization tool. And operation system is, it is platform independent. On any platform, or you can be able to install the Docker. And the official URL is www.docker.com. Here I just mentioned the link here. By using the link, you can be able to download the Docker desktop on your local machine as well. Okay guys, and here I'm going to mention some key Docker terminologies. Here one is Dockerfile. Guys, there are a lot of terminologies are there. So here the Docker is not a simple subject. It is a vast subject. There are a lot of things which we can explore. Like I'm going to cover some kind of basic things which can be helpful for you as a beginners. Then if you are looking for the in-depth knowledge about the Docker, then please refer the AWS sessions which I have made. I had made some kind of wonderful content in the AWS sessions. Then that will be very helpful for you. So even though I had made some kind of content in these sessions as well, then let us understand the Dockerfile. Dockerfile is a simple text file that contains all the commands to build an image. Guys, if I want to create a container, first of all I need Docker image. Here the Dockerfile, why Dockerfile has been used? Dockerfile is used to automate the Docker image creation. If you want to create any kind of customized image, then you are going to create a Dockerfile. In Dockerfile, you are going to mention all the commands which are required in order to create your Docker image. Without having the Docker image, you cannot be able to create the Docker container. Remember this guys. If you want to create a container, the first prerequisite is you must have a Docker image. And we have some kind of default images are there which can be available over the internet. Suppose if you want to make any customized image with the help of the Dockerfile, you can be able to create the Docker image. Fine. Here we have the Docker compose files are there, the Docker volumes. Volumes are nothing but just like disks. So how we are going to attach the disks to the VMs. In the similar way, we are going to attach the volumes to the Docker containers, Docker Swarm. Docker Swarm is just like a, if you want to run the same service over the multiple nodes. Here we are going to maintain the Docker containers at the cluster level. Here if you have a multiple nodes, assume nodes are VMs. So you are going to make this all the nodes into one cluster. You are going to make one service to be able to run all the multiple nodes. So Docker service, Docker Swarm is a kind of orchestration which can be at cluster level. And Docker Compose is, if you want to make entire application to launch in the single server, you are going to use the Docker Compose. Here both you are going to implement YAML files. There are a lot of commands are there, so you can explore yourself regarding this. And this is the basic introduction. And I'm going to move to the further slide. Here, yes, we had already discussed, Docker file is used to automate the Docker image creation. And Docker image is nothing but it consists of all the things which are required to create a container. Docker image is lightweight, standalone, executable package that includes everything need to run a piece of software, where we can be able to have each and everything which are required to run our application. Without Docker image, we cannot be able to create the container. Guys, let us see the flow, how the flow happen. Here we have the Docker file. From the Docker file, what I will do, by building the Docker file, I can be able to create the Docker image. So once the Docker image has been created, you are going to create the container from the Docker image. And at the same time, you want to save your image. Where you are going to save image? Here the Docker is going to provide some kind of registry. Docker Hub is the Docker default registry where you can be able to save your images or to pull the images as a sum. Where in Docker Hub you can be able to find out the some kind of default images, like a Tomcat application server, like some kind of Nginx server. So whatever the image you want, you can be simply able to pull those default images. Suppose some some developer has developed some kind of image, they are simply put in the Docker Hub. Even though from zero you are going to develop an image, instead of doing that, what you will do, simply you can pull the image from the Docker Hub, and with the help of the image you can be able to run the container. Okay, from Docker file we can be able to create the Docker image. From the Docker image we are going to create the container. Okay guys, and while creating the Docker file, first thing we need to consider as from base image. This is the Tomcat 8.0 is the base image, and here we have a lot of commands are there while we creating the Docker file, like from, copy, cmd, entry point. There are a lot of commands are there guys, so you can explore by searching the Docker file in the internet. Then you will get a lot of commands how we can be able to create the Docker file. Then if I get the if I have any kind of possibility, then I'm going to show to you how to create the Docker file as well. And so let us move to the another slide. So why containers? So developer care because it is going to quickly create ready to run packaged applications, low cost deploy and reply. And because of these compatible features, the developers are using containers in order to quickly develop their applications. And IT cares because of it is going to improve the speed and frequency. And if the speed has been improved, what we can increase the frequency of releases, reliability of deployments. It's make app lifecycle efficient, consistent and repeatable. If we can configure once, we can be able to run many times. So there are a lot of features guys, so by using the Docker. And one more thing guys, you just need to understand the Docker architecture. Here this is very important guys, you just need to understand this. Here generally what we have these components. Docker client. Docker client is the command line interface where the user can be able to communicate with the Docker. Means if you want to communicate with the Docker, then you need some kind of interface. So Docker client is going to provide such kind of interface in order to communicate with the Docker engine. Whether you are a user, you need to communicate with Docker or not. Yes. So how you can be able to communicate with the help of the Docker client? You can be able to communicate with the Docker simply by executing the command. The commands will be executed over the Docker daemon. Means Docker daemon execute the commands sent by the user. By using the Docker client, you are going to execute the commands. Where the commands are going to execute? In the Docker daemon only. So here in the Docker daemon, what are the commands which I want to execute? It is going to execute over the Docker daemon, and commands may be installing a OS or pulling an image from the registry. There are a lot of operations which we can do on Docker daemon. Docker registry. What do you mean by Docker registry? Suppose if I have the image, I just want to save the image in a secure place. Here, the Docker registry is the place where I can be able to push the image, to pull the image, to save the image, just like a GitHub repository. In GitHub repository, what we will do? We are going to save our code, manage code, we can keep our code, we can push the code, we can pull the code, we can do a lot of this. In the similar way, in the Docker registry as well, Docker Hub, where we can be able to push the image, to pull the image, to store the image, and we can fetch the default images. There are a lot of things which we can do with the help of the Docker Hub as well. Okay guys, and fine, and come to the, there are, what are the advantages of Docker? I had mentioned a lot of things here, so don't worry guys, so just please have a look on this. Then, and one more thing guys, you just need to understand about the monolithic and microservices architecture. This is very critical guys. You need to understand about what is monolithic and what is microservices. So in order to show that, so just a moment, I am going to share. So where it is, no. So I'm going to show to guys, just a moment, just bear with me. So go to desktop. So here, yes, this is the guys. So here, if you think about the monolithic architecture, what do you mean by monolithic? Suppose if you consider an application that is Paytm, assume that is a Paytm. So in Paytm, you have n number of services there. You have electricity bill, you have mobile prepaid service. There are a lot of services which are running over the Paytm application. Paytm is an application. Inside of the application, we have n number of services. Suppose if an application consists of n number of services, and all these services are included in one server, means all these services you are going to deploy in a single server, then that will be called as a monolithic architecture. Means whatever the services you have which consist of your application, all these services you are going to deploy in one server, that will be called as monolithic. Every monolithic architecture has only one database. Means this entire application has a only one database irrespective of a number of services which you are going to run inside of your application. Here, suppose if any service went down, suppose assume the movie ticket service is going down because of some kind of issue, it is going to impact the other services which are running inside of your application. That will create some kind of business loss. Suppose if there is issue in the movie tickets, then what will happen with the bus ticket? Then what will happen with the train tickets? Is that going to impact? Because of this movie ticket, it is going to impact the other services which are running inside of the application. So it is creating some kind of business loss or not? Yes, obviously it is going to create some kind of business loss for me. Here my requirement is, even though one of the service is going to down, it is not going to impact the other services which is going to run inside of my application. Suppose there is some kind of database issue is there. Suppose if the database issue is there, it is going to impact all the services or not? Obviously yes, because of all the services have the single database only. If this database has been impacted, then it is going to impact all the services which has been connected to this database. So I want to isolate. So then how that will be achieved? Here the microservices comes into picture. I am going to show to you guys. Here, instead of instead of deploying all the services in a single server, what I will do here, if an application contains of n number of services, every service has a individual services. Means if I have the multiple servers or multiple services, for each service I am going to create one server. If and each server has an individual database. Okay, here microservice. Suppose it is a movie ticket. It is a IRCTC, railway tickets. It is a current bills, power bills. So if any of the microservice has down, it is not going to impact the other services which are going to run over the same application. Means for each service I am going to create one server, and each server has an individual database. If any impact happened to the any server, it is going to impact only for that particular service only. It is not going to impact the other services which are going to run over the same application. This will be achieved with the help of the microservices architecture. Here one more thing guys, if you create one server for one service, that is going to make a lot of cost to you, because of creation of server is not so easy. We need to pay the bill. If you are creating the Azure, suppose if you are going to create the infrastructure in the on-premises, you need to purchase a server. The server purchasing is not that much, its capital cost is lot more. So but here you need to make effective utilization. How that will be done? So here the Docker container comes into picture. So what you will do, you are going to take the bare metal server. On top of the bare metal server, what you will do, you are going to install operating system. On top of the operating system, you are going to install the Docker engine. On top of the Docker engine, you are going to create the multiple containers, and you are going to run each service as a separate server. Here you are not going to create the VMs. Here you are going to create the containers. With the help of the containers, you are going to run your services on top of the container. Here, so in that way you can be able to effectively utilize your hardware. At the same time, you can be able to run your multiple services over multiple servers. If any of the service or server or container has went down, it is not going to impact the other containers which are running over the same mission. So in this way we can be able to achieve high reliability, cost saving, effective utilization, fast deployment, and zero downtime. If one of the services went down, it is not going to impact your entire application. Your application will be in the running state only. Only the users who are connected to that particular service only facing the issue. The rest users who are using the other services in your application, it is not going to impact the other users or other services which are running inside of your application. This is the basic difference about the microservices and the Docker container, and sorry, microservices and monolithic. Okay guys, and here I had mentioned some kind of comparison scenarios. So this is all about the Docker and Docker components and the difference between the monolithic and microservices. Okay guys, I hope you guys understood the session. Thank you so much guys for your support. If you like my video, please subscribe and share these videos with your friends. And thank you so much for your support guys, and I will meet up you in the next session with a new topic. Until signing off, thank you, bye bye.